Assalamu alaikum friends. Welcome back to ChemMystery Unlocked. Before we start, if you're finding these lectures helpful, make sure to join our WhatsApp group where I will be sharing resources and answering your doubts there too. The link is in the description, so don't miss out. In today's lecture, we will be covering metallic bond and features of ionic compounds. Let's start with metallic bond. A metallic bond. What is a metallic bond? A metallic bond is the force of attraction between positive metal ions and a sea of delocalized electrons. मेटेलिक बॉन्ड हमारे पास फोर्स ऑफ अट्रैक्शन है पॉजिटिव मेटल आयंस और इलेक्ट्रॉन्स के बीच में. अब इलेक्ट्रॉन्स हमारे पास नेगेटिवली चार्ज होते हैं, ऑलवेज रिमेंबर दैट. So, this is a force of attraction that keeps the positive metal ions and sea of delocalized electrons together. Like it keeps them together, like holds them together with each other. So, this is metallic bond. Now, let's move ahead on to strength. This bond gives metals many of their unique properties like conductivity and strength. But what affects the strength of this bond? It depends on two main factors. What are the factors? The first one is number of delocalized electrons. Always remember, more electrons means stronger bonding. जितने ज़्यादा हमारे पास इलेक्ट्रॉन्स होंगे उतनी हमारे पास स्ट्रॉन्गर बॉन्डिंग होगी. And the second one is the size of metal atom, atomic radius. Smaller atoms mean stronger attraction. जितने हमारे पास smaller atoms होंगे उतनी हमारे पास stronger attraction होगी. Now let's move ahead. Why do some metals have weak bonds? कुछ metals के weak bonds क्यों होते हैं? Metals with a large atomic radius have a weaker force of attraction between the nucleus and outer electrons. So, their outer electrons are more easily delocalized, making the bond weaker. We discussed this in our previous lectures too. अगर metals का atomic radius ज़्यादा होगा तो उसके न्यूक्लियस और आउटर इलेक्ट्रॉन्स के बीच में अट्रैक्शन कम होगी because the distance will be way too much, so the attraction will be weaker, force of attraction will be weaker. इस वजह से इलेक्ट्रॉन्स आसानी से फ्री हो जाते हैं. इलेक्ट्रॉन्स आर मोर इजीली delocalized, मेकिंग द बॉन्ड वीकर, और बॉन्ड वीक हो जाता है हमारे पास. लेट्स मूव ऑन टू अरेंजमेंट इन मेटल्स नाउ. Let's see this. Metal ions are arranged in a regular lattice. As you can see, metal ions are arranged. These are the positive metal ions. They are arranged in a regular lattice and surrounded by a sea of delocalized electrons. Where are the electrons? These are the electrons, these red ones. ये हमारे पास red वाले जो हैं electrons हैं. As you can see, metal ions are surrounded by the sea of delocalized electrons. The electrons are everywhere surrounding the positive metal ions. What can electrons do? Electrons which can conduct electricity. Always remember, electrons can conduct electricity due to their free movement. Like they move everywhere. And look at this, layers which can slide over each other. Positive metal ions layers can slide over each other. Always remember these points. Let's move ahead on to properties of metals now. Properties of metals पे चलते हैं अब हम. There are three properties of metals. Good conductors of electricity. Metals can carry electricity, but why? In metals, electrons are delocalized. They can move freely, allowing electricity to flow easily. Always remember, due to free moving electrons, they allow electricity to flow easily. The second one is they are malleable and ductile. Layers of metal ions can slide over each other. Let me give you a detail. Metals can be hammered into sheets, which means they are malleable, or drawn into wires, which means they are ductile. Because metal ions can slide without breaking bonds, metals can change shape without shattering. So they're malleable and ductile. Layers can slide over each other. Always remember this. Now let's move ahead on to the third one. High melting and boiling points. Strong metallic bonds need more energy to break. Metals stay solid at high temperatures. What holds them together so tightly? Metals have strong metallic bonds. The positive metal ions are held together by the sea of delocalized electrons. अब एक क्वेश्चन आएगा दिमाग में. You might be thinking कि to melt or boil a metal we need to break those strong bonds. So answer is that yes, that takes a lot of energy. That is why metals have high melting and boiling points. Always remember these points because they need more energy to break. हमारे पास मेल्टिंग और बॉइलिंग पॉइंट इसलिए हाई होते हैं क्योंकि मेटेलिक बॉन्ड्स हमारे पास बहुत स्ट्रांग होते हैं और उसको ब्रेक करने के लिए हमें बहुत ज़्यादा एनर्जी चाहिए होती है. Now let's move on to bonding type based on reactants. As you can see on your screen, metal plus non-metal forms an ionic bond. Metal loses an electron and a non-metal gains an electron. And in this, non-metal plus non-metal forms a covalent bond. This is covalent bonding. Non-metal gains an electron and this one also gains an electron. But in the third scenario, metal plus metal, there is no bonding. Why don't metals bond with other metals to form compounds easily? Metals don't usually form ionic or covalent bonds with each other. That is because metals tend to lose electrons, not gain them. हमारे पास metal lose करते हैं electrons, gain नहीं करते. In ionic bonding, one atom loses electrons, which is metal. Metal loses an electron and the other gains electrons, which is non-metal. But when two metals meet, both want to lose electron. No one wants to take them. जब भी हमारे पास दोनों metals meet करेंगे तो हमारे पास वो दोनों लूज करना चाहेंगे इलेक्ट्रॉन्स पर कोई गेन नहीं करना चाहेगा. अच्छा, in covalent bonding, atoms share electrons. Always remember, they share electrons. But metals don't easily form this kind of bond, either because they already have delocalized electrons. So instead of forming metal plus metal, which results in no bonding, metals don't combine with other metals to form compounds. Let's move ahead now onto features of ionic compounds. Let's break down the key features of ionic compounds now. These are important to understand, especially when we deal with bonding and properties of substances. Let's see the first point. Ionic compounds are usually solid at room temperature because they consist of oppositely charged ions arranged in a strong, rigid lattice structure. Ionic compounds हमारे पास किस तरह बनते हैं? Ionic compounds are formed by the bonding of a metal and a non-metal. So हमारे पास सॉलिड क्यों होते हैं? अब ये रूम टेम्परेचर पे ये इसलिए सॉलिड होते हैं बिकॉज दे आर मेड अप ऑफ अपोजिटली चार्ज्ड आयंस. मेटल इज अ पॉजिटिव चार्ज्ड आयन एंड अ नॉन मेटल इज अ नेगेटिव चार्ज्ड आयन. So they are held together in a strong rigid lattice structure. This structure is like a solid 3D grid, keeping the ions locked in place. Now let's move on to the second point. They have high melting points due to strong electrostatic forces between the ions. A large amount of energy is needed to break these bonds. हमारे पास इलेक्ट्रोस्टैटिक फोर्सेस बहुत ज़्यादा स्ट्रांग होती हैं आयोनिक बॉन्ड्स में. सो बिटवीन द आयंस, सो हमारे को बहुत ज़्यादा एनर्जी चाहिए होती है. इट टेक्स अ लॉट ऑफ एनर्जी टू ब्रेक दीज बॉन्ड्स. So therefore the melting point is higher, as we discussed in our last slide. Let's move on to the third point now. Ionic compounds do not conduct electricity in the solid state because the ions are fixed in place and cannot move freely. In solids, always remember the ions are stuck in place, they can't move. And if the charged particles can't move, इलेक्ट्रिसिटी कैन फ्लो. जब तक हमारे पास चार्ज पार्टिकल्स मूव नहीं कर सकेंगे, इलेक्ट्रिसिटी फ्लो ही नहीं कर सकेगी, तो फायदा ही नहीं. तो हमारे पास ionic compounds do not conduct electricity in solid state. Now let's move on to the fourth point. They conduct electricity in molten, liquid and aqueous state because the ions become free to move and carry charge. Always remember this, they conduct electricity when molten or dissolved in water. When you melt them or dissolve them, the ions are free to move around, and once the ions are mobile, they can carry electric charge. हम लोग जब भी इनको मेल्ट या फिर डिसॉल्व करेंगे, आयंस फ्रीली मूव कर सकते हैं. So they can carry electric charge, but solid में नहीं कर सकते. So to summarize, strong bonds, high melting points, no conduction in solid, but good conductors when molten or in solution. These are the hallmarks of ionic compounds. Or these are the easiest points. Always just remember them. Let's move ahead on to, let's talk about electrical conductivity now. For a substance to conduct electricity, it must have free moving charged particles. हमारे पास अगर सब्सटेंस को कंडक्ट करनी है इलेक्ट्रिसिटी, तो फ्री मूविंग चार्ज पार्टिकल होने चाहिए उसके पास, ताकि वो कंडक्ट कर ले इलेक्ट्रिसिटी. These can either be free moving electrons or free moving ions. ये या तो फ्री मूविंग इलेक्ट्रॉन्स हो सकते हैं या फिर फ्री मूविंग आयंस हो सकते हैं. These are present in all metals, which is why metals are good conductors of electricity. ये हमारे पास हर तरीके के मेटल में प्रेजेंट होते हैं. फ्री मूविंग इलेक्ट्रॉन्स आर प्रेजेंट इन ऑल मेटल्स, इसलिए हमारे पास all metals are good conductors of electricity. Another good example is graphite. अ फॉर्म ऑफ कार्बन, ये हमारे पास कार्बन की फॉर्म का होता है। ऑल्दो इट्स नॉट अ मेटल, ये मेटल नहीं है। इट कंडक्ट्स इलेक्ट्रिसिटी बिकॉज इट हैज डीलोकलाइज्ड इलेक्ट्रॉन्स दैट आर फ्री टू मूव। इसके पास भी हमारे ग्रेफाइट के पास भी डीलोकलाइज्ड इलेक्ट्रॉन्स होते हैं जो कि मूव करते हैं, और इसी वजह से ये भी इलेक्ट्रिसिटी कंडक्ट कर सकता है। नाउ लेट्स मूव ऑन टू फ्री मूविंग आयंस। Ionic compounds only conduct electricity when molten or dissolved in water, which means aqueous. In solid form, the ions are fixed in place and can't move. हमारे पास free moving ions, ionic compounds हमारे पास electricity conduct करते हैं जब वो molten या फिर dissolved in water, aqueous उसमें हो state में, तो वो कंडक्ट करते हैं इलेक्ट्रिसिटी ड्यू टू फ्री मूविंग आयंस, जबकि सॉलिड फॉर्म में नहीं कर सकते क्योंकि हमारे पास आयंस फिक्स प्लेस में होते हैं और मूव नहीं कर सकते। सिमिलरली aqueous solution of acids like HCl or H2SO4 also conduct electricity. This is because acids dissociate in water to release H positive ions which are mobile and carry charge. हमारे पास डिसोसिएट का मतलब होता है कि दे ब्रेक इन वाटर टू रिलीज H पॉजिटिव आयंस, वो ब्रेक हो जाते हैं वाटर में जाके और फिर H पॉजिटिव आयंस रिलीज करने लगते हैं जो कि कैरी करते हैं चार्ज। सो इस वजह से इट कंडक्ट्स इलेक्ट्रिसिटी। So in summary, metals and graphite conduct using electrons. Molten aqueous ionic compounds and acids conduct using free moving ions. Now let's move ahead. Let's look at how ions behave in different states. Ions किस तरह behave करते हैं different states में। In the solid state, ions are closely packed and cannot move freely. But in the molten state or when dissolved in water, aqueous solution, the ions become free to move. Solid state में ions tightly packed होते हैं, as you can see over here, the example of NaCl. These are in the solid state right now. They are tightly packed. बिल्कुल भी गैप नहीं है, as you can see. Okay. They are in a fixed arrangement. You can see this. Okay. Now let's move ahead on to when we melt it. How the Na, sodium and chloride ions are closely packed. You can see over here. Because of this, they cannot move freely. So solid ionic compounds do not conduct electricity. There is no movement of electrons. Electrons are stuck. But what happens when we melt it or dissolve it in water? When we melt sodium chloride, the strong bonds between the ions break. The ions become free to move. Since the ions are now mobile, molten sodium chloride can conduct electricity. As you can see, there's a huge gap now, so ions can move freely, and so therefore electricity can be conducted. आप लोग देख सकते हैं इसमें हमारे पास टाइटली पैक्ड हैं, सो इलेक्ट्रॉन्स मूव नहीं कर सकते। देन हमने मेल्ट कर दिया। अब मेल्ट किया तो स्ट्रॉन्ग बॉन्ड्स बिटवीन आयंस ब्रेक हो गई, ये दूर दूर हो गए। एज दे मूव फार फ्रॉम ईच अदर, गैप्स बढ़ गए। गैप्स बढ़ गए तो हमारे पास मूवमेंट ऑफ इलेक्ट्रॉन्स होने लग गई, मूवमेंट ऑफ आयंस होने लग गई। इधर क्योंकि आयनिक कंपाउंड है तो मूवमेंट ऑफ आयन होगी. Now look here. When sodium chloride is dissolved in water, it forms an aqueous solution. Again, the sodium ion and chloride ion separate and are free to move in the water. So, just like molten NaCl, aqueous NaCl also conducts electricity. ये हमारे पास जाके एक्वस सॉल्यूशन हमारे पास वो ions free to move हो गए, so it can conduct electricity. क्योंकि गैप बढ़ गया तो हमारे पास ions freely move करेंगे. Now let's move ahead on to the ionic lattice or crystal lattice. This is the ionic lattice or crystal structure of sodium chloride. The yellow balls are sodium ions, as you can see. These yellow ones are sodium ions. And the pink ones are the chloride ions. This is the pink one. There are many. They are arranged in a regular repeating pattern held together by strong electrostatic forces. Now, there's a force keeping them together, like holding them together. So that is the electrostatic force, the strong electrostatic force between them. By the way, the melting point of sodium chloride is approximately 801 degrees Celsius. हमारे पास melting point sodium chloride का होता है 801 degree Celsius. Just remember that. Because of these strong forces, sodium chloride has a high melting point around 801 degrees Celsius. A lot of energy is needed to break this lattice क्योंकि हमारे पास बहुत हाई है मेल्टिंग पॉइंट, तो एनर्जी ज़्यादा लगेगी, सो हाई मेल्टिंग पॉइंट होगा. लेट्स मूव अहेड ऑन टू मैग्नीशियम ऑक्साइड नाउ. Okay, the melting point of magnesium oxide is approximately 2800 डिग्री सेल्सियस. हमारे पास मेल्टिंग पॉइंट मैग्नीशियम ऑक्साइड का 2800 डिग्री सेल्सियस है. ये हमारे पास हायर है देन द सोडियम क्लोराइड. सोडियम क्लोराइड का था 801 डिग्री सेल्सियस. मैग्नीशियम ऑक्साइड is 2800 degree Celsius. Magnesium oxide has higher melting point than sodium chloride because of stronger electrostatic forces due to higher charge. There are stronger electrostatic forces between magnesium oxide than the sodium chloride. So the melting point is higher. And these higher charges create much stronger bonds than the positive one and negative one charge in NaCl. So more charge equals to stronger attraction. And stronger attraction equals to higher melting point. This is a key point. Always remember this point. कि जितना ज़्यादा चार्ज होगा उतनी हमारे पास अट्रैक्शन स्ट्रोंगर होगी, और जितनी हमारे पास अट्रैक्शन स्ट्रोंगर होगी उतना हायर मेल्टिंग पॉइंट होगा, क्योंकि हमें ज़्यादा एनर्जी चाहिए होगी टू ब्रेक द बॉन्ड्स. Each ion is closely surrounded by 6 ions of the opposite charge. Now take a look at this diagram. On the right, the red spheres represent the oxide ions. The green ones represent magnesium ions. You will see that each ion is surrounded by 6 ions of the opposite charge. Look at this magnesium ion. It is surrounded by 6 oppositely charged oxide ions. And same is with the oxide ions that they are surrounded by 6 oppositely charged magnesium ions. This type of arrangement is called a giant ionic lattice, which gives the structure strength and contributes to the high melting point. ये हमारे पास जायंट आयोनिक लैटिस कहलाया जाता है ये अरेंजमेंट, और ये स्ट्रक्चर स्ट्रेंथ और कंट्रीब्यूट करता है हायर मेल्टिंग पॉइंट पे. नाउ वेयर डू वी यूज मैग्नीशियम ऑक्साइड? हम मैग्नीशियम ऑक्साइड को कहाँ यूज करते हैं आप? Because it can withstand high temperatures. It's a refractory material. That means it's used in places that deal with a lot of heat. हमारे पास ये हाई टेम्परेचर्स को संभाल सकता है, मतलब मैग्नीशियम ऑक्साइड. तो ये रिफ्रैक्टिंग मटेरियल है, एंड ये जहाँ पे हीट का काम ज़्यादा यूज होता है वहाँ पे यूज होता है. ये हीट के जहाँ पे वो होते हैं ना चीज़ें, उधर ज़्यादा यूज होता है. इसके हमारे पास टू कॉमन यूजेस हैं. देयर आर यूजेस ऑफ रिफ्रैक्टरी मटेरियल्स आर लाइनिंग ऑफ फर्नेसेस, and the second one is electrical insulators because it does not conduct electricity in solid form. ये हमारे पास सॉलिड फॉर्म में इलेक्ट्रिसिटी नहीं कंडक्ट कर सकता, तो इलेक्ट्रिकल इंसुलेटर्स में यूज हो सकता है. हमने आज के लिए बहुत कर लिया. इंशाल्लाह मैं मिलता हूँ नेक्स्ट लेक्चर के साथ. तब तक दुआओं में खास याद रखिएगा. अल्लाह हाफिज़.